Welcome to Lesson 47, Encryption, the silent guard that turns stolen data into useless data. Picture a laptop swiped at the airport. With encryption, the thief walks away with a paperweight. Without it, you're staring down identity theft and a corporate breach. Over the next few pieces, we'll cover at rest versus in transit, the OS-level tools like BitLocker and FileVault, TLS on the wire, and the part that trips up most junior techs, managing recovery keys when things go sideways. Before we touch any tools, you need the mental map. Data lives in three states: at rest, sleeping on a disk; in transit, flying across a network; and in use, being crunched by the CPU. At rest, that's BitLocker or FileVault territory. Full disk encryption turns a stolen drive into random noise. In transit, TLS wraps the connection so the coffee shop Wi-Fi creep just sees gibberish. In use is the bleeding edge, Intel SGX Apple Secure Enclave, mostly a cloud concern. The takeaway for a junior tech: it's never one or the other. On every new device setup, you confirm both disk encryption and TLS are on, encrypted everywhere, or you've left a door open. Now here's the good news on disk encryption. Every modern OS ships with it built in, and you just need to flip the switch. On Windows Pro or Enterprise, that's BitLocker, leaning on the TPM chip and quietly backing the recovery key up to the Microsoft account. On Macs, FileVault has been standard since 2011, and on Apple Silicon, it's basically free performance-wise. But that recovery key shows up exactly once, so save it. Linux uses LX, set up during install, with up to 8 key slots and no safety net if you lose them all. The golden rule: enable it on first boot before data piles up. Encrypting a full terabyte later costs you half a day. Encrypting an empty drive takes minutes. So disk encryption handles the laptop. But that's just step one of a much longer journey. Picture a user typing their password. It sits at rest on their machine, travels across Wi-Fi and the open internet, lands in server memory, and finally rests in a database. 4 out of those 5 stages we can lock down: BitLocker or FileVault at the laptop, TLS 1.3 across the wire, AES at rest in the database. The weak link every time is stage 4, server memory. To actually process your password, the server has to decrypt it, which means a database admin with the right access can read it in the clear. Confidential computing will fix that someday. But in 2026, it's still rare. So the rule is simple: encrypt at every step you can, and assume that one exposed link is why we layer defenses in the first place. Now let's talk about that wire between laptop and server. That's TLS territory, and it's what puts the S in HTTPS. 4 things to lock in. The padlock icon means encrypted and verified. No padlock means anyone on the Wi-Fi reads it. Certificates are the Trust Foundation X509, signed by a CA like Let's Encrypt, and you never ever click through a cert error on an unknown site. TLS 1.3 is the current standard. Anything below 1.2 is dead, and SSLlabs.com is your go-to checker. And when an internal app throws a self-signed warning, the fix isn't just click through. That trains bad habits. Add the cert to the trust store or get a proper one. Document it in the ticket. Now here's where encryption bites back if you're sloppy. Lose the key, lose the data. There's no support line that can recover it. So 4 habits to burn in. 1. When BitLocker, FileVault, or LUKS generate that recovery key at setup, save it immediately. Microsoft account, iCloud, password vault. Print it in a safe, anywhere except the encrypted drive itself. 2. In a domain environment, BitLocker keys escrow straight into Active Directory or Intune, and Tier 2 pulls them with get-add-object in seconds. Verify that pipeline works during onboarding, not during an outage. 3. When a ticket comes in saying BitLocker won't unlock, you verify identity first, then check Microsoft account for personal devices or AD for corporate, hand over the 48-digit key, and document it. And 4. Rotate keys on a schedule. TLS certs every 1 to 3 years. PKI yearly for high security. Set it and forget it is just a future incident with a delay timer. All right, let's put this to work. 4 tickets you'll genuinely see, read them, decide your move, then check. Stolen laptop? Your first question isn't where, it's was full disk encryption on? If yes, you've got a hardware loss, not a breach. BitLocker prompting for the recovery key usually means a TPM hiccup after a firmware or boot change. Verify identity, hand over the 48 digits, then investigate why it triggered. Browser cert warning. Never tell the user to click through. Check the URL. Run it through SSL Labs. Escalate if it's legit. And when someone asks how to encrypt a file for email, that's a teaching moment. 7-zip for quick wins, SMIME or PGP when it matters, and always confirm the recipient can actually decrypt it. Before we wrap, lock in this vocabulary. These 12 terms show up in every ticket, every policy, every audit you'll touch. 3 states of data: at rest on disk, in transit across the network, in use while being processed. AES 256 is your symmetric workhorse. TLS 1.3 is modern HTTPS, and the TPM is that little chip holding your BitLocker key. Recovery key saves you. FDE is the umbrella term, and certificates plus PKI are how trust actually gets proven on the wire. Know these cold and you'll follow any security conversation in the room. Now, 5 myths you'll hear constantly and need to shut down politely. The performance complaint is dead. Modern CPUs do AES in hardware, so BitLocker costs you about 1%. Password-protected zips only count if you picked AES 256, not the default zip crypto. HTTPS protects the connection, not the website. Scammers get padlocks too. Nothing to hide ignores that encryption is about control over your bank, medical, and work data. And quantum won't break AES 256 anytime soon. Symmetric crypto is safe, and post-quantum standards are already rolling out. And that's lesson 47 in the bag. Encryption at rest, encryption in transit, BitLocker or File Vault on every machine, TLS 1.3 on every connection, and recovery keys saved somewhere you can actually find them. Next up, lesson 48, incident response with the NIST framework. Detect, contain, eradicate, recover, learn. Because when prevention fails, you need to know your first 30 minutes cold. 1 lesson and the capstone left in stage 6. See you there.